In this video, we're going to look at some more complex types of differential equations so that we can see where the growth and decay formula comes from that you learned about last year. So in order to do that, we do need to kind of briefly start explaining the method of separation of variables. And that's just us making sure our variables are corresponding. So remember that y prime is the same as dy dx. And remember that when we are integrating, everything has to line up. So technically, we're taking dx to the other side, okay? And so that we get dy equals 3x over y dy. And what we've been doing this whole time without actually writing it is integrating really both sides. And when we integrate dy, technically that's 1 dy, so 1 is the derivative of just y. And so that's how we get back to the original. What we're going to have to do now is make sure we're really looking at both sides. Whoops, wrong button. Really looking at both sides because everything has to correspond. And over here, we have a problem, and I actually wrote that wrong. But we have a problem because this says we're supposed to be respecting x, and there's this y here. So we do need to get rid of that by multiplying it to the other side so that we get y dy equals 3x dx. Now we're set up for integration. So when we integrate, we're going to follow that power rule just like we have been. We're going to add 1 to our exponent. We're going to divide. On the other side, again, we're going to add 1 to the exponent. We're going to divide, and we are going to put the plus c. There is no reason to put plus c on both sides because we're finding a general solution. And so that c is just some random constant that we're never going to find. If this is some constant and this is a different constant, and let's say I subtract the 2, a constant minus another constant is still just a constant. So since we're never going to worry about it, we only put it up there once. And then the problem does say solve, so we are finding that original function. So if I get y by itself, I'm going to multiply the whole thing by 2. I see that y squared equals 3x squared. And again, here, 2 times c is just some other constant. Finally, last step, I am going to take the square root of both sides, and I get y equals plus or minus the square root of 3x squared plus c. And that c does have to stay in here because it is part of that addition. Okay, so again, just a note at the bottom, make sure we don't need to add constants to both sides. Our results are going to be the same. So the second example, we're not actually going to finish for time's sake, but I do want to make sure that we're in the habit of understanding this whole separation of variables, and then we'll do more complex problems in the next video. So if I take this to the other side, I'm going to end up with dy equals 2 minus y times dx. Again, my variables do not correspond, so I do need to take that 2 minus y to the other side by dividing. And when I do that, I get 1 over 2 minus y times dy. On this side, I get dx. And now this is set up for integration. The reason we're skipping is you would have to use u substitution here, and it does become, it just takes time to do all that. So the important part of this video, which is why it's in this box, is this formula here, y equals ce to the kt power. This is the formula for continuous exponential growth and decay that's always compounding continuously. So maybe you remember this from last year. I think last year you called it PERT. Unfortunately, we can't always use that acronym because P stands for principal, which is your initial amount of money, and we deal with a lot of other things than money. So sometimes it will be money, but a lot of times it's not. So we just use a more generic formula in calculus. And this is what we do anytime we see the words exponential growth and decay. Also, anytime they tell us that the derivative is proportional to the original. And so it could be written in words like this, or it could be written out in equation form. But anytime they say the derivative is proportional to y, that word proportional just means we're going to multiply it by a constant. That's how we make things proportional. If this is the formula that we're given, if we integrate this, we're going to get this formula for exponential growth and decay every single time. So we can look at how that is in class, but that's what we're always going to get. So let's look at an example. Here we have different types of information. we have an original value. And one thing I didn't mention is that if this is the formula we're doing, K is always that proportionality constant, and C is always our initial value. So if you know the formula is going to hold true, then you automatically know that C is that initial value, and you don't actually have to work that out. So in our problem here, it kind of gives us this initial value. So in 2008, that's our initial value of 530,000. And we know that this follows an exponential pattern. So I know my final answer is going to be in this form where C is that initial value. They also give us an ordered pair. So because in this form, T is my independent variable and Y is my dependent variable, the ordered pair they give me is that in 2010, which was 2 years after we began, our revenue was $386,000. Okay. K is the only thing in here that's not a variable. We need to find K. I lied. C is also not a variable, but we already know C. So we have to find K, because T and Y should be the only variables in this problem. So we're going to use the information that we have. Our Y value that we're going to use right now is 386,000 equals C, which is this initial value, times e to the kt power. K is what we're looking for, and the time now is 2 years. So I need to solve this for K. And the first thing we're going to do is divide by 530,000. And when I do that, we're just going to divide each of these by 2. And so I get 193 all over 265. And I'm still solving for K. So I need to use the natural log of both sides in order to cancel the E. And so I get the natural log, the natural log equals, of 193 over 265 equals 2K. And then to isolate the K, I'm going to divide by 2 or multiply by 1/2. So I can see this is what I get for the value of K. So now that I know all the parts to my equation, I can go ahead and write out my generic equation. So Y equals that initial value times E K T. Now K we just found to be 1/2 ln 193 all over 265, and that's times T. So this is my generic model for this problem. Now the question says, what is the revenue? So what is our total amount of money in 2012, which was 4 years after we started. So what we need to do now is plug in 4, and you would have a calculator for these types of questions of e to the 1/2 ln 193 all over 265 times 4. And that would give us our revenue in the year 2012.